In this problem, a person is holding a kettlebell in the air, and we're asked to find the magnitude of the total force exerted by the shoulder. To solve this problem, we will need to know how to balance the forces in both the x and y directions and the conditions required for static equilibrium. These are that the sum of all torques and the sum of all forces must both be equal to 0. The forces acting in this situation are the force of gravity acting on the kettlebell, the force of gravity acting on the arm, the force supplied by the deltoid muscle, and the force supplied by the shoulder. This force acts in some angle from the horizontal, which we don't know, so it's going to have both an x and y component, which we'll need to find. The other piece of information that we'll need to know in order to solve it is that the deltoid force is equal to 882.9 newtons, and we found this number in a previous video. In order to find the x component of the force applied by the shoulder, we sum all the forces in the x direction and set their sum equal to 0. The only forces acting in the x direction are the x component of the shoulder force and the force supplied by the deltoid muscle. We solve this equation for the x component of the shoulder force to find that it is equal to 882.9 newtons. To find the y component of the shoulder force, we sum all of the forces acting in the y direction and set that sum equal to 0. These forces are the y component of the shoulder force and the two gravity forces, one acting on the arm and the other acting on the kettlebell. We solve this equation for the shoulder force y component and then substitute in the numbers that we know to find that the y component of the shoulder force is 107.91 newtons. Now that we know its x and y components, we can calculate the total magnitude of the force exerted by the shoulder muscle using the Pythagorean theorem. We substitute in the numbers we just found and find that the force exerted by the shoulder is 889.5 newtons.